So computer instructions, these are three types of instructions. So what are the first type of what are the three types? Memory reference instructions, register reference instructions, and last one is input output instructions. Okay. So what are the types? Memory reference instructions, register reference instructions, then input and output instructions. Okay. Now, in memory reference instructions, I will use the memory. Okay. So I will use the memory, whereas in register reference instructions, I will not use any memory. Okay. Then input output instructions. So before we'll go to the first type of instructions, that is memory reference instructions. Now, anyone, rule number 8, Chepamma, what is the 15th bit? 15th bit is called as I. What is I? I is nothing but which decides whether it is direct addressing or indirect addressing. So when it is direct addressing, ఎవరైనా చెప్పండమ్మా, మనం ఆల్రెడీ చెప్పాము ఇది. When I equal to 0, it is nothing but what? Direct addressing. I equal to 0 is nothing but direct addressing. Okay. When I equal to 1 is called as the indirect addressing. Okay. And when it is direct addressing, what is the condition? Opcode followed by the address of the operand. Whereas when it is indirect addressing, opcode followed by address of the operand. Okay. Now can roll number 8, what is the opcode? Here it is present. Choose చెప్పండి. Opcode ఎంత ఉందో చెప్పండి. 000 to 110. So those many combinations I will get. So ఇప్పుడు మీరు చెప్పండి అమ్మా. When I is 0, opcode is 000. So what is the total number? 4 zeros. 4 zeros means in decimal, what is the value? అర్థమైందమ్మా? When I is 0, opcode is 000. So 4 zeros. 4 zeros can you convert into hexadecimal? What is the answer? 4 zeros మార్చండి hexadecimal లో. ఆన్సర్ ఏంటి? hexadecimal లో మారిస్తే 4 zeros ని is 0 only. Okay. Is 0 only. Okay. Now next one. Take I is 0 and opcode 000 తర్వాత నెక్స్ట్ టైం వస్తుంది చెప్పమ్మా. 001. Yes, very good. Now convert this into hexadecimal. 0001 is what value? 0001 is nothing but called as 1. Okay. 1. Are you understand? Now if you take instead of 001, 010 you take, then what is the value? Now first case I take and consider opcode as 000, second case 001, and next case what is the value I have to take? 0 0 1 0. Can anyone, what is this value? 2. Very good. So like that, up to what value? Up to what value? Opcode, what is the last opcode? 0110. Very good. What is the value of 0110? 6. Very good. So these many. Okay. So we'll get. So opcode. What is the opcode? Opcode is nothing but what is the operation we are performing. It depends on the opcode. Okay. Then I already said I is 0 means direct addressing. 1 means indirect addressing. Indirecting addressing. Indirect addressing, opcode followed by the address of the operand. Whereas I equal to 1, it is indirect addressing. Opcode followed by the address of the operand. Okay. So this is the first type. Then second one ఏంటో చూడండి అమ్మా. Register. Second one is nothing but register reference instructions. Okay. Choose చెప్పండి అమ్మా. What is the opcode? ఇక్కడ ఏముందో చెక్ చేయండి. What is the opcode here they given? It is predefined. What is the value? 111. 11. And what is the I value? 0. So for register reference instructions, always the I value is 0 and opcode is 111. So 0111 ని hexadecimal number లో చెప్పండి. ఏంటి వాల్యూ? 0111 అంటే 7, sir. Very good. So 0111 means it is starts from 7 and remaining you have 12 bits. Okay. So 12 bits you can write as any values. Okay. So 3, any values you can write. Okay, so it always starts from 7, so try to remember that. So for register reference instructions, always what is the I bit? I bit is 0, opcode is 111. Okay, then similarly last case చూడండి, input output instructions లో కంపేర్ చేయండి. సో వాట్ ఇస్ ద I bit here? చెక్ చేయండి అమ్మా, I bit ఏంటి?
1, sir.
1, and opcode is always 111. Now you can substitute చేయండి, 1 1 1 1. So can anyone, what is the value of this? చెప్పండి, దీని వాల్యూ
15, sir.
15 means in hexadecimal I required. Hexadecimal, what is the value? So it is
F.
yes, very good. So it is F. So I will ask now one question. If a instruction starts from 7, it is what type of instruction? Memory reference, register reference, input output instruction.
Register, sir.
So it is a register reference instructions. Okay, and one more doubt you might have, sir, whether I will get 7 in memory reference? No, because the final opcode is only 110, so it is always 0110. Okay, so 0110, so it is 6, otherwise 1110, so that is not 7. Okay, 7 means always it is register reference instruction, and input output instruction means it is always starts from F. Okay, now see the next slide. Is the slide is visible to you? The slide is visible?
Yes, sir.
Very good. And see the first case. Ivanni means instructions amma. So here 3 different types are there. First one is memory. First one is memory reference instructions, whereas second one is register reference instructions, and third one is input output instructions. Is it okay, all of you? All of you understand what I'm saying? First case lo cheppandi, I value anta. In first case I already said I is 0, you take 0, you take. Okay, so I 0, I bit is 0, then opcode is 000. Okay, I 0, 000, so total value is 0. So see here also we have 0. Is it okay? Are you understanding? Is 0 and remaining 12 bits. Similarly 0 triple X means what is the operation? End operation. End operation between what? End memory word to AC. End memory word to AC ante meaning entama? Can anyone? End memory word ante a operand which is present in the memory location, you have to do end operation with accumulator, and you have to store that result in accumulator. You have to store that result in accumulator. Okay. Okay. Is it visible? The slide is visible now?
Yes, sir.
Cheppandi end value. So whenever it is 0 triple X, you are doing the end operation between memory location operand with accumulator, and final result you have to store in the accumulator. Okay. Final result you have to store in the accumulator. So accumulator is represented by AC. Okay. And similarly next instruction cheppandamma, 1 triple X. What is the operation that you are doing? Add. Add ante ento cheppandamma? Addition operation. Addition operation with whom you have to do? In memory location, whatever is there, that you have to do AND operation with accumulator and store that result in accumulator. Okay. Then next one LDA. LDA and to triple X. So what is the description? Load accumulator from memory. And the meaning yesterday I already said in memory some operands will be there. So from that memory you are copying into accumulator. Are you understand? Load accumulator means memory, whatever operand is there, that you are storing in the accumulator. Okay. Then STA, 3 to 2x. Store the content of accumulator in memory. Okay. Then next one, branch and conditional, 4 triplex. So branch and conditional means the meaning is, suppose you are a student, you are executing one program and suddenly you will get one more program. Then what you have to do? You have to skip this. You have to definitely attend the program 2. So initially you are executing the program 1. Now you will get an interrupt of program 2. Then you have to leave the program 1 and then you have to go for program 2. Okay. That is called as branch unconditionally. Okay. The next one is BSA, 5 triplex. So branch and save return address. Okay. ISZ, 6 triplex. Increment and skip if 0. And all these instructions individually I will discuss in the next topic, next topic. Okay. Once again, there is a separate side heading, memory reference instructions, register reference instructions, where we will discuss. Okay. Now similarly, I1 తీసుకుంటాము. Last slide లో ఒకటి చెప్పాను. I1 తీసుకుంటే ఏమవుతుందో చెప్పాను. When I is 1, ఎవరన్నా ఒకళ్ళు చెప్పినమ్మా, I is 1 అయితే ఏమవుతుంది?
Direct.
When I is 1 direct, and here it is 000. Starting up code is 000, no? 1000 means what's the number? Hexadecimal number? Up code ఎక్కడి నుంచి ఉందమ్మా? 000 to 110. So take I is 1, up code is 000. 1000 అంటే hexadecimal number ఎంత? 8. So 8 triple X. Okay. So this is also same operation, that is AND memory word to accumulator. Okay. But it is indirect addressing mode. Okay. The only change is it is indirect. And 9 triple X అనేది ఎప్పుడు వస్తుంది చెప్పండి? I is 1 and opcode is 00. So 1001 అంటే meaning ఏంటి? Is 9. So 9 means add memory word to accumulator. Okay. Add memory word to accumulator. Okay. And next similarly A. When you will get A in anyone, which opcode I have to take? I is 1, opcode is 010. So 1010 అంటే ఏంటి? A. So like that. Okay. Like that, these are the memory reference instructions. All these instructions we will discuss individually. Okay. And but in memory reference instructions, you always use the memory. Whereas in register reference instructions, we will not use the memory. చెప్పండి. So register reference మీకు ఆల్రెడీ చెప్పాను. It starts from what value? 0111. 0111 అంటే వాల్యూ ఎంత? 0111 అంటే is 7. Okay. And remaining 12 bits are represented by XX. It may be any value, no problem. Okay. So always when it starts from 7, it is a register reference instruction. 7800 అంటే మీనింగ్ అంటే చెప్పండి. ఇక్కడ ఏముందో చూడండి. CLA అంటే ఏంటి? Clear accumulator. Now I'll ask one question. Suppose AC is some value. Okay. AC is assumed that some value between 4. మీరు చెప్పండి అమ్మా, CL అంటే ఏమవుతుందో చెప్పండి. CL అంటే ఏముంది? డిస్క్రిప్షన్ చెక్ చేయండి. క్లియర్ అక్యుములేటర్. క్లియర్ అక్యుములేటర్ అంటే ఏమవుతుంది? అక్యుములేటర్ వాల్యూ. This is only an example. Okay. So when clear accumulator, we will get accumulator value is 0. Are you understand what I say? It is simple. Then 7400 అంటే CLE అంటే clear register. Okay. Then 7200 CMA complement accumulator. Okay. Like that. Suppose accumulator value is 1. Now execute CMA. Can anyone? What's the answer? Rule number 8, answer upon CMA. Assume that accumulator value is
1. Or 0, sir.
complement accumulator. Complement accumulator and
0.
wherever 1 is there, that you have to invert as 0. Okay. Complement you have to take because 1's complement is 0, like that. Then 7100 and complement. So like that 7080. It is nothing but circular right with AC and E. 7040 and circular left, AC and E. Then increment 7020. So like that, okay. Then last case input output instructions. Input output instructions lo evana check cheyandamma. Input output instructions meeku already cheppa. It starts from what value? Starts from what value? Yes. So whenever any instruction is starts from F hex code, then it is the input output instruction. F800 ante meaning entamma? Input character to AC. F400 ante these are already predefined. Okay. You can ask that, sir, why only they given input for F800? Because when they design the basic computer, these are the basic instructions they consider. Okay. F400, it is nothing but output character from AC. Then F200, this is nothing but SKI, skip on input flag. Then F100, SKO, this is skip on output flag. Then F080, ION, that is nothing but interrupt on. Then last one F040, it is nothing but interrupt off. Is it okay?
So what do you mean by skip on input flag and skip on output flag?
That's what. See, while if you are executing the input devices, when you enter some data, there will be we'll get the input flag. Okay, when that input flag is 1, then you have to skip. Okay, and these instructions will be explained with the example. Then you will understand. But here you just understand that skip on input flag. Okay.
Okay, sir.
It means when input flag is some value, we have to skip that time. Okay. But those instructions will be seen later. Is everyone is okay? Or you understand what I said? So these are the basic computer instructions, and next one we'll see the control unit. Okay. So next topic that we will see the control signals. Wait for 1 minute. Is the PPT is visible to you?
Yes, sir.
Okay, okay. The next one is timing and control. Before to understand the timing and control, I will explain everything. Okay, but you try to go through. Okay, try to read the textbook also. So timing and control. That means whenever you are executing some instruction, always based on that opcode, based on the instruction code, we have to initiate the different micro operations. Okay, sequentially. Okay, that is the purpose of the timing and control signals. And try to remember, see whatever registers are there, registers in control unit, and all registers which are present in the computer, all those are controlled by one clock generator that is called as the master clock generator. Okay. I do understand the timing for all the registers in a basic computer is controlled by a master clock generator. Okay. And these clock pulses are applied to all, okay, flip-flops and registers, including the flip-flops and registers in control unit also, okay. And see, whenever you want to change the value in the register, that means that clock pulse cannot change the value in the register. At the same time, it must have a control signal. When it is has a control signal, then only you can change. The meaning of control signal is, we will understand here, okay. I will show. Now in this diagram, we are applying all clocks, okay. Is it visible for everyone? So this clock is applying for all registers, but when you apply this register, this clock signal, this value can't be changed. When loading, if you are active, then only you can load the data into address register. Are you understand? LD, INR, CLR are called as the control inputs. When LD is 1, then only I can load the data from bus into address register. It not only depends on clock and LD input has to be active. Then only you can load the data which is present on the bus into address register. Is it okay? Are you understand what I said? Then the control signals. The control signal and what control signals are generated in the control unit in general, and those are the inputs for the multiplexers in the common bus and control inputs for processor registers. Okay, and the control unit we can design in two ways. Okay, hardware control unit and microprogram control unit. Hardware control unit is nothing but we can build this with the help of the combination circuits. Okay, whereas microprogram control unit we will build with the help of the micro programs which are stored in the control memory. Okay, so that's what here I written. So hardware control unit, the control logic implemented with the gates, flip-flops, decoders, and digital circuits. Okay. And whereas in microprogram control unit, it is nothing but a program that you have to store in the control memory. Okay. Now this is the control unit of your basic computer. Okay? Control unit of your basic computer. Okay. Can anyone see what are the block diagram? All of you. Under block diagram, also check check Roll number 20 to 30. Your attendance. 20 to 30.
21 present, sir.
Entama?
21 present, sir.
Next చెప్పండి ఇవాళ చెప్పండి
Sir, 23 present.
Check next.
26 friends.
Next. మిగతా అందరూ అబ్సెంట్ అయినా 23 వరకే ఉన్నారా
26, sir.
17, sir.
ఎంతమ్మా
17.
20 to 30 అడిగాను అంతే నెక్స్ట్ 31 to 40 చెప్పండి
32 present, sir.
31 present, sir.
34 present, sir.
40 present, sir.
And 41 to 50 చెప్పండి
44 present,
42
sir.
present, sir. 42 present, sir.
30?
42.
Okay.
44, sir.
40.
Hmm.
45, sir.
Hmm.
Sir, 39, sir.
Okay, very good. Then 41 to 50 చెప్పండి. 41 చెప్పండి అమ్మా. నెక్స్ట్ ఓకే అన్మ్యూట్ చేయండి. నెక్స్ట్ 41 to 50 అందరూ ఆబ్సెంట్ అయినా ఒక నెంబర్ చెప్పారు అంతే. Forty-one to 50. Okay. Next 51 to 50.
Sir, 45, sir.
What's up?
42, sir.
Sir, 11.
11 కాదమ్మా నేను అడుగుతుంది 41 నుంచి 50 అడుగుతుంది. Next 51 to 60. 51 to 60 all are absent.
60.
Sir, 57 present.
Understanding what I'm saying? 57. So next topic is the control unit of a basic computer. Okay. Control unit of a basic computer. Now see the diagram. Already it is there. See the instruction register which holds the instruction code. You already know 15th bit is called as I, and 14, 13, 12 are called as the opcode, and 0 to 11 is called as the address of the operand or address of the operand. Okay. And the opcode will be decoded by using a decoder 3/8, and we will generate corresponding signal D0 to D7, and we will apply that as an input to the control logic gates. Okay. Then similarly the control logic gates we are applying the 0 to 11 bits. Okay, 0 to 11 bits. At the same time we are applying some more inputs. Okay, then 4-bit sequence counter. So initially it will be starts from 0, and each time it will be incremented by 1. So initially it is 0. Whenever it is 0 means it will be decoded by the decoder and you will get T0. When sequence counter is incremented by 1, we will get T1. Sequence counter is incremented by 2, then we will get T2. And like that, the final signal is whenever it is triple 4 ones, then it is 15, T15. And once again it will be incremented to T0. Okay. It will be executed step by step. So this is the control unit of the basic computer, and try to verify all of you the block diagram. Okay. Anyway, I will explain this. So go through this, and if you have any doubt, you can ask. Okay. Or you understand what I'm saying?
Yes, sir.
57 check diagram. So I0 అంటే మీనింగ్ ఏంటో చెప్పండి అమ్మా ఎవరన్నా. I0 అంటే మీనింగ్ ఏంటో చెప్పండి.
Indirect address.
I0 అంటే డైరెక్ట్ అడ్రసింగ్ మోడ్. I1 is nothing but indirect addressing mode. Okay. And 12 to 14 bits are called as opcode bits, and which are decoded by 3/8 decoder. And what are the decoder outputs? It is D0 to D7. Okay. Then what is sequence counter? Suggest చెప్పండి, what is sequence counter? So initially sequence counter is value is 0. When it is 0, that is decoded by sequence decoder, it will activate the T0 signal. Okay. When sequence counter is incremented by 1, then here this decoder will decode this incremented value by T1. So like that. So we try to go through this, all of you. And if you have any difficulty, you try to ask. And this diagram I will explain tomorrow. Is it okay? And if you have any doubt, just inform to me. Okay. If you are not asking anything, that means I don't know whether you are understanding or not understanding. Is it okay?
So do we have to memorize the circuit diagram, the previous one?
And this one you have to remember. Okay. This is the basic structure of the control limit. So you have to remember. Okay. Suppose if it is a descriptive exam, I will ask in the exam. So draw the block diagram of the control unit for a basic computer. Then you have to draw this and then you have to explain this. Today I doesn't explain total part. So for this I have to explain with respect to this clock. Okay. For this diagram, you have to explain with respect to the clock signals. Is it okay? I understand what I am saying.
Yes, sir.
So try to go through this and try to go through the instructions, and if you have any doubt, you can ask. Okay. And tomorrow I will explain this control unit. I explained only descriptive part, and now tomorrow I will explain with respect to this operation. Okay. Now here, whenever D3 is active and T4 is active, then we have to clear the sequence counter. I will explain. Okay, with respect to time diagram, explain. Okay. So go through this in the instructions and go through it. If any doubt, you can ask. Okay. I already sent this PPT. You try to go through it. Okay. I'm roll number 30 to 60. Are you understanding what I am saying? 30 to 60 Japan. Roll number 30 to 60. Are you understanding what I am saying or not? ఎవరైనా చెప్పండి రా 30 to 60. మీరు ఇలానే ఉండండి. Roll number 1 to 30. 1 to 30. Are you understanding what I am saying?
Yes, sir.
Okay. Try to go through it. If you have any doubt, you can ask. Okay.
Excuse me, sir.
చెప్పండి చెప్పండి.
Sir, 33 present, sir. ఇందాక ఇంటర్నెట్ కనెక్షన్ బాగాలేకుండే.
అర్థమవుతుందా క్లాసు? 33.
Sir, yes, sir. సగంలో నాకు పోతుంది. అస్సలు బాగాలేదు ఇవాళ కనెక్షన్.
ఓకే, చూడండి, చదవండి, ఏమన్నా డౌట్ ఉంటే చెప్పండి. ఓకే,
ఓకే సార్, థ్యాంక్ యూ.
నెక్స్ట్ ఇంకో క్లాస్ ఉంది అప్పుడే అడిగి ఉంటుంది, అడిగి పోదు ఆఫ్ అవ్వదు. So all of you go through the computer instruction topic, and if you have any difficulty, just inform to me. Okay? Is the voice is audible? What I'm saying?
Yes, sir.
ఇప్పుడు వినపడుతుందమ్మా?
వినిపిస్తుంది, sir.
Are you understanding what I'm saying?
Yes, sir.
Hello?
So can you share this PDF?
ఈ సిస్టమ్ అసలే షెడ్కి వెళ్ళింది, నువ్వు దీన్ని అటు ఇటు కదిలించిన పోయింది. Okay, ma'am, I'm closing the session. So try to go to topic computer instructions and timing and control logic. Okay, if you have any doubt, you can ask. Okay, is the
So can you share the notes, sir?
I already sent PPT, no?
So for unit 2, you didn't send, sir.
I sent chapter 5 and chapter 6 to your CRs. You just ask them to forward. Chapter 5, chapter 6, I send one soft copy PPT. That is unit 2. Okay. I will send. If you require me, you just put a WhatsApp message to me. I will forward you. Okay.
Okay, sir.